Alright, today we're going to be looking at Boyle's Law and Charles' Law and how we are going to be able to calculate those two different laws. So we're going to start off with Boyle's Law first. So we're going to start with our formula sheet as you see in front of you here. So number 4 is going to be Boyle's Law. And when you're looking at Boyle's Law, we're going to set it up similar to this where we're never going to solve for one of the variables. So we're first going to have our first pressure is equal to our second pressure times our second volume divided by our first volume. Our second pressure is equal to our first pressure times our first volume divided by our second volume. We're never going to solve for the first volume, so we're only going to be looking at our second volume here. So it's going to be our first pressure times our first volume divided by our second pressure. So therefore we're going to have P and V. So P, as we said, is pressure. V is volume. Because remember, Boyle's Law, temperatures are held constant. So pressure, you're going to see it as kPa, because they're going to do a lot of it in kilopascals because it's going to be a large unit. And for our volume, you're going to see that it's going to be in liters. So we're going to look at some examples for these problems here. So therefore, I'm going to look at page 98. And I'm going to go through some examples with you here. Alright, so on page 98, number 1, we know we're going to have P1, V1, P2, V2. So it says a flask contains 155 centimeters cubed of hydrogen at a pressure of 22.5 kilopascals. Under what pressure would the gas have a volume of 90 centimeters cubed at the same temperature? Alright, so our first one is going to be 155 centimeters cubed, so that's our first volume. Then we have 22.5 kilopascals, so that's our first pressure. And then we had 90 centimeters cubed. So we're going to solve for the second pressure. So if we look for second pressure, it's going to be P1 V1 over V2. So 22.5 times 155 divided by 90. So 22.5 times 155 would give you 3,487.5 divided by 90 to give you 38.75 kilopascals. Okay, number 2. If the pressure exerted on a 300 milliliter sample of hydrogen gas is at a constant temperature is increased from 0.5 kilopascals to 0.75 kilopascals, what's the final volume of the sample? So our first volume is 300 milliliters. They said it started at 0.5 kilopascals, so that's our P1, because that's where it started from. And then it said it went to 0.75 kilopascals, so that's our second pressure. So we're going to solve for our second volume. So our second volume is going to be our first pressure times our first volume divided by our second pressure. So P1 V1 divided by P2. So we're going to have 0.5 times 300 divided by 0.75. So 0.5 times 300 would give you 150 divided by 0.75. should give you 200 milliliters for your answer. Okay, number 3. A sample of hydrogen gas has a volume of 150 milliliters at a pressure of 0.947 kilopascals. If the temperature remains constant, what would the volume of the gas be if the pressure is 1 kilopascal? So they gave us our first volume of 150 milliliters, and that was at a pressure of 0.947 kilopascals, and it said that it went to 1 kilopascal. So our second volume is our first pressure times our first volume divided by our second pressure. So 0.947 times 150 divided by 1. So 0.947 times 150. And then if you divide it by 1, you're still going to get the same answer. So it's going to be 142.05 milliliters.